All right. Okay. So again, just for the recording's sake, I am Red. I'm the president of the team. Today we're going to have various speakers today who will be also talking about different aspects of the team. And together, everyone in this team of about 30 members works together to keep the team strong, going, and provide everyone with a unique, fun, and educational experience. So, yep, that was just, again, a bit of an introduction of all the people. Yeah, so who are we? The first thing to really know about the team is that we're an engineering design team that has been around for about 30 years now, just a bit over that. And we've always participated in the Baja SAE competition, which is an intercollegiate design series as part As part of this, we have to design, build, test, and compete in a new car every year. I'll take you through a bit of what each of these steps entails. So the first thing that's needed in any engineering design project is to design and model the end product. We use a range of softwares to not only create 3D models of our car, but also use software to analyze the strength and motions of parts and assemblies. We also use software to create programs for our automated machinery to create custom parts, which is something we'll talk about more in a bit. The past year, we've worked very hard to change our car from rear-wheel drive, in which just the rear wheels are powered, to four-wheel drive, in which all four wheels are powered. This was a change that was required by the rules, and a lot of the work that we're going to be doing this semester will be very focused on refining that design, which will be a very good learning opportunity for a lot of the new members. So here you can see a bit of just some of the software and things that we do, especially in 3D modeling, which is known as CAD, computer-aided design. On the bottom left is just a full render of our car, which is based off of the complete model that we managed to complete last year. Top left shows us a bit of the suspension and just mostly just top view, likewise, as does the bottom right, showing our rear suspension. The top right shows a FEA, which is a finite element analysis, which lets us really analyze the forces and the stresses that are going on in the part. So once we've designed our car, we need to be able to make it. So we have a number of facilities on campus that we're allowed to use, including an office for logistical and design work, sheds and a proving ground for testing, and a shop for fabrication. The shop is where we do all of our fabrication work and has always been used basically around the clock. Most of the parts of our car are made by ourselves, with a few exceptions with things that might be too difficult to make, like tires, or things we might just not have the resources to do, like, let's say, something like powder coating. To make our parts, we have to use a variety of machines such as those listed here, so like mills, lathes, fill presses, and whatnot. And at the moment, we're not allowed to access our shop and office just because CS is not allowing teams to have any like in-person meetings. But we will resume fabrication work as soon as we're allowed to. But again, in the meanwhile, we'll be focusing all of our efforts on design work. So as things are built and really finished up, we need to make sure that the car itself is going to run correctly and that we can really validate our simulation and analyses. Because more often than not, real world conditions are pretty different from what we expect, whether that be just like the magnitude of the load or like, you know, what direction it's flying, or even if there's a load there at all. So testing allows us to really see what's actually going on with the part. And in order to do this, we have to use a wide range of sensors and equipment. Some of these things include things like strain gauges to determine the stresses in parts, things like thermocouples to measure the temperature of components, and a variety of other sensors. We're able to perform a wide range of dynamic tests on our proving grounds, which is located roughly in the South Campus area, just like by the Heretic region. Especially with the implementation of our four-wheel drive system, we need to do a lot more validation of our designs. And as such, are planning on putting a larger emphasis on preparing for testing. For those of you who will be interested in more of the electrical stuff, this is where you'll be doing a lot of the work and it'll be a lot more up your alley. So once everything is designed, we have to take the car to the Baja SAE competition. So the competition itself is a 4-day internationally attended competition. Usually about 100 teams will attend. They're hosted in 3 locations per year, and we only really attend one of these. The locations can vary from places like Oregon, Illinois, Kansas, Maryland, basically wherever there's like a nice track or nice open area to do so. So among these 4 days, the first 2 days are really the static events. So day 1 consists of basically just a check-in, an engine check, and what's known as a sales presentation, in which you have to pitch your design to a hypothetical business to get them to invest, because you want to create 4,000 units of your vehicle in a year. The second day consists of various events such as the tech inspection to make sure that our cars are following all the necessary rules and that they're safe, a brake check to ensure that the brakes on the car work, and then a design presentation, which is where we really pitch our design and our validation and testing to judges, and they score us based off of that. So with the third day and the fourth day, that's really when the dynamic events start, and that's when the cars are actually allowed to move about and such and actually operate. The third day consists of various dynamic events, including acceleration runs, which test the car's acceleration in a given distance, a maneuverability track, which really tests your car's handling, especially with regards to tight turns and whatnot, a suspension and traction run, which really throws your car crazy. There's actually a video of this, which I'll show in a moment. Another one is, or an example of this would be a rock crawl, kind of like the one shown here, which we're actually getting lifted out of. This was in 2017 Illinois, and essentially these rocks can get very, very big. We also have a hill climb, in which your car has to go up a really steep hill as quickly as possible. So this is a video of our suspension and traction course from Rochester in 2019. Wait, no, this is the hill climb, because I have the suspension and traction one next. But you can see from the hill climb that this one it goes up pretty steep, and the dirt is very loose and not very packed. So that creates a lot of issues when it comes to actually being able to get up the hill properly. This is the video of the suspension and traction course. This is from Rochester 2019, and we actually got 6th place in this. You can see as the car goes along, it's kind of flopping all about, especially because there's a lot of obstacles on the course. Yep. So that was one of the toughest courses that we've gone up on. We actually, as I said, got 6th place in that. Only 13 teams were actually able to complete it, and of all of the about 60 or 70 who even attempted. Yes. The 4th day is the endurance race. And so the endurance race is really the biggest event in the competition. All the teams will race at once, and you can see in a photo here of all the teams grading up just before the start of the race. Essentially, you have 4 hours to complete as many laps as possible. So that means even if you have a really fast car, if you're not staying in the race for very long, you're not going to win. It's all about making sure that your car is durable enough to withstand this. And the endurance race can be covered with a wide variety of obstacles, such as rocks, trenches, logs, moguls, boulders, basically anything that they can really throw on the track to get in our way, they pretty much will. So this is a video of the endurance race from Rochester 2019. You can see that it starts off and being like absolutely crazy with just a lot of cars on the track. As time goes along, it does thin out, but you do have a decent amount of like proximity to other cars generally. Yep. So you can see that there's a lot on that course. You know, you even saw some amount of tires, you saw all forms of turns and hills and whatnot. It can be very, very difficult of a course and will often really test your car's like whether or not it's built well at all. So essentially with competition, it ends up being the really the payoff of a year's worth of hard work. And one of the things to understand is that a lot of effort has to be put in, not just to the building of the car, but the designing and the validation of it. And it ends up being a very rewarding experience for everyone. I can tell you that pretty much, I think anyone in this team would agree that competition is probably one of the best parts of the year. And it's just always so fun. And it's important to note that it's not always a serious tone. We do have a lot of fun aside from just, you know, just the car stuff. We'll often go to eat together as a team. We'll go around the local area to do things like in 2018, we actually toured one of the last diesel electric submarines that was in the US Navy, if not the last. It was the USS Blueback, for those of you who are wondering. Aside from that, a lot of shenanigans also tend to happen as well. There have been, so for example, the picture on the right, one of our members fell asleep, so we decided to start putting a lot of car parts on him until pretty much at one point he woke up. He was asleep for a while though. Other like really wacky things happened. Like we had one time we were eating a breakfast, I think, and one of our members just started drinking bottles of maple syrup, and then he tried blueberry syrup, which is apparently better. But yeah, it is indeed unhealthy. But the important thing to understand is that we're not all just work, and that competition is not just rewarding because you get to see the car really perform well, but also because you get to spend a lot of time with the people who you've been working alongside for a year or more. So an important thing to understand is that this team can be a lot of work, but it's really up to you how much you want to be able to commit. And especially with this coming semester, things are going to be playing out a bit differently. So if there's a bit of, if things do get a bit rough or aren't operating smoothly, this is kind of one of the things to kind of take into account. So while we have no shop access, we will be doing entirely design work. So we still do have a lot of things to do ahead. For those of you who do join, if you're interested in doing mechanical work, you'll be incorporated a lot more into the design process of the car. If you're interested in doing electrical work, you'll be helping a lot with implementing various sensors and microcontrollers that we can, so that we can eventually test the car when we get back into our facilities. And if you're interested in software, you'll be doing a range of work from making programs to optimize the design process, to programming testing equipment, to like even just like managing our website. Everything will be taught to everyone, so absolutely no experience is required. And one of the things that, especially for the people who are doing mechanical stuff, as you get to learn the design more, it'll set you up for success when we finally get back into the shop, because understanding the design of the part really helps for fabricating it. So being in this team allows you to also really practically apply the skills you learn in your classes. This may not seem very important for a student just starting out in university, especially for the freshmen, but the majority of engineers in the field can really tell you that they learn the most valuable information after they started working in their field. It allows them to actually use things they learned, and more importantly, learn how real life situations affect their design. Our team is good with that in that it actually does heavily involve the engineering design cycle, and that you get a lot of hands-on experience all before you graduate. So essentially, a lot of our members will be able to hit the ground running as soon as they get a job. Another bonus of being affiliated with a team is that the connections that you'll make at career fairs. There are various gatherings during the year with companies that look to hire SBU students, particularly which, again, are the career fairs. A lot of companies will send SBU alumni to the fairs during them, and we actually have a lot of former members present at these companies. We've had alumni representatives from Brookhaven National Labs, GE, and at times that Ford has been at the career fair, also them. Even if you don't necessarily meet them at career fair, our alumni do love giving back to the team in whatever way they can, especially because the team gave so much to them. A lot of our alumni know how much we've learned and done. And the alumni themselves, because of their experience, have also made great impressions on employers. And that means that they're always willing to put in a good word for us at their companies. This has gotten various members pretty good opportunities. We've had members who've gotten internships at places like Northrop Grumman, Brookhaven National Labs, Borg Warner, Ford. In addition to all of this, there are also career fairs at the competition itself. There are various companies that go there, including the sponsor companies. We've had companies there like Polaris, Honda, Blue Origin, which is essentially the Amazon equivalent of SpaceX. And all the companies that are there know just how experienced that we are, especially because they can even see all of that in front of them. So at the end of the day, the team really does allow you to develop your professional skills as well. So in terms of joining, we still do have a bit more to talk about, but I just wanted to talk about this first. So again, absolutely no experience is necessary. We will teach you everything you need to know, and sure, having experience is definitely helpful, but again, as we're really committed to making sure that everyone is able to learn everything they need to do. You can also commit as much time as you want. Some people will come down to some people will do Baja work basically every moment of the week. Some will only do 1 or 2 hours. As long as you're willing to help out, we're more than happy to accept that. When we are in person, one of the 2 requirements to join is to take a few quick safety courses. They're really simple. It's like, do you drink this acid? Do you touch the spinning blade of death? The answer to both of those is obviously yes, but it's all just pretty much common sense. The only requirement that actually stands currently, because we're not in the shop and office, is to join our Slack. The link for the resources page on our website, which I'll show in the next slide, is in this QR code. So if you want to, I would say scan it as soon as possible. Another thing is that for those of you, especially who are in mech, you'll be aware of the MEC 225 class. Essentially, it teaches you about how to use and operate heavy machinery. So when fabrication actually does happen, in order to use our heavy machinery, such as our mills and lathes, you do have to have MEC 225, but there will still be plenty of other fabrication work that can be done without it. And again, our website has more info, which is in this QR code, or stonybrookmotorsports.com. If you go under the resources and join page, it'll redirect you to the forums, or you can just go directly to resources and forum. Again, this will detail all the requirements that you need to join. For this specific instance, you only need to worry about point 2, because for point 1, which is completing 3 online safety courses, you don't need to do that at the moment because we're not going to be in the shop. So it's highly unlikely that someone's going to be getting injured unless they try really hard. But you never know. So in terms of weekly operations, I will be passing this off to Max.
All right, hello people. My name is Maxime or Max, and I'm the fabrication leader this year. So we as a team are always working on a variety of tasks that include design work, machining, and testing. We also sometimes do small side projects that end up just upgrading our club locations. So at the start of each semester, the subsystem leaders and the board members come together to make a schedule for office hours to ensure that there's always somebody in the shop or the office during the weekdays. Anybody can come down during these hours to help out with any task the person is working on, independent on which subsystem you choose to finalize yourself in. It's also a good way to meet your or a subsystem leader. And then through Slack, you can also contact anybody to set up a more convenient time if those hours aren't really good for you. So during a typical week, you can usually find us especially during the weekdays. So turning parts on lathes, going through different operations on a CNC machine, cutting and notching tubes for the frames, jigging up different components on the chassis table, welding different parts together, and many other tasks that just change kind of on a weekly basis. Sometimes we bring out a thermoformer to make the body panels on the car, which I can say I helped build when I first started at the club. The fact is, most of the car components are made in-house, which means we have a lot of work to do in these 2 semesters. We have a strict yet somewhat flexible schedule that always ensures that we're on track with everything that has to be done. This also means there's always stuff to be done down at the shop, even though we don't have access to it this semester. During the week, we hold general body meetings where we discuss our weekly progress and upcoming events. So this semester we'll be holding our GBMs on Fridays at 5 p.m. We also meet up on Discord Wednesday nights at 9 for game night if anybody's interested. But on Saturdays is when we have our main weekly fabrication meeting where most of the club comes down to the shop and works on everything that needs to be done. The shop is usually packed during those Saturday meetings and we make a lot of progress. We also usually use this time to send people to our off-campus facilities and more importantly to test on our racetrack. And then Sundays is the Lord's Day, but it's also our day of rest. So usually there isn't really anybody in the shop during that day, except for when there's like a deadline coming up and people might still be there on Sundays. But so now I will pass it on to the system leaders to present their system, starting with Funes.
Hello, my name is Christian Funes. I'm the powertrain system lead. So powertrain, the funnest one of them all. We have 3 major pillars: design, fabricate, and test. So for design work, so a lot of our work is done through SolidWorks in design. So SolidWorks does everything from the CAD modeling all the way through the FEA analysis and any other types of analysis that we need to do in order to validate our models. If you look on the pictures I have over here, you can see this one part that's kind of like colorful with like blue, red, and all that. So that is one part that basically transfers the powers to the wheels, and we have to ensure that under full power of the engine, this part won't break. So we do this thing called FEA analysis, finite element analysis, and we can plug in what kind of forces this part will see and where it's going to be held down, and ensure that under operation, it's not going to break. So there's also just general CAD modeling. So you can see these parts, all of the ones that look like it's from a computer are from a computer. We just basically put up some designs and some sketches, and then you dimension them out. We decide what is best for whatever we need to fit, and for our car in general. So there's a lot of work to do with design. It's very design like heavy, also very fabrication heavy. So fabrication also takes up about half of our work. So you can see over here in the middle section, there is a design of our rear gearbox. And then below that, you can see the actual physical model. So the casing of this gearbox was one of the most fabrication intensive things we do. It takes almost like upwards of a month to make because it starts off as one giant block of aluminum. And using the CNC mill, we can accurately down to a 1/10 of a 1,000th of an inch make all these features and geometry in order to physically house all these gears and everything like that. So that takes a lot of time because we have to remove so much material, and the machine just has to go at it for so long. But in the end, we can get something super precise that we know it won't fail on us, and we know every component will fit in there. So there's a lot of work to do fabrication wise on the CNC mills, just also the end mills in general, and any other tool. This really encompasses everything that we have in the shop. Finally, we have testing. And so in testing, we do a lot of things from CVT testing to making sure that some of these parts won't break. For example, the second picture from the top on the right side, that is our axle. That's what powers the wheels. It brings the power from the gearbox to the wheels. There's a very long tube, and we have to make sure that that tube doesn't break, so we can do strain gauge testing in order to figure out what's the maximum torque we can have on this shaft before something fails. Also, we do a lot of testing on the actual car, especially in CVT. CVT testing involves taking out the car and putting different tune-ups inside the CVT, so that way we can get different acceleration profiles. So a lot of the time they're out there testing the car in person over in our proving grounds. So any of these three aspects of the car interest you, Powertrain does it all. So it's very interesting. There's a lot of work to do. We have three major subsystems: gearbox, axles and drive shaft, and CVT. So the gearbox entails, we're going to have three now with the new iteration of the car. And then we have axles and drive shaft. So that's all the shafts basically throughout the car. We're going to have about 4 of those or 5 of those. Kind of 6, a lot of them. And then CVT is all the acceleration tuning that they do. So they don't really make stuff. It's really test heavy because we don't make the CVT. So if you were interested in testing and getting this car to maximum performance with maximum effort, that's also really down your street. And so yeah, that's Powertrain. That's all I really have so far. If you're interested in any of this, let anyone know, and they'll just direct you over to whoever you need to, probably me. But yeah, thank you very much. I can hand it off now to Neha for vehicle dynamics.
Hello, I'm Neha, and I'm the vehicle dynamic system lead, the funnest system of them all, so it's definitely not Powertrain. So vehicle dynamics really just deals with the handling characteristics, driver feedback, and pretty much just making sure that the car stops as a whole. So we have 3 main subsystems that fall under vehicle dynamics, which are steering, suspension, and brakes. So steering is pretty simplistic. It is kind of the connection between the driver and the vehicle, because if the driver wants to turn, obviously you want the car to turn with it as well. So we use a rack and pinion system for our steering, which translates the rotational motion from the steering wheel to linear motion on the tires, pretty much. The next subsystem that we have is suspension, which is responsible for mitigating the forces that the car is experiencing. So if you go over bumps and droops, obviously you don't want all the components as well as the driver itself to really feel that impact. So we try to suppress those forces as much as possible. So in the front of the car, we have a short, long arm system, and in the rear, we have a multi-link system. That's kind of just like fancy terms for the different components that we're going to be using. And we also use Fox air shocks on our vehicle as well, even though we're looking into different shocks that we could possibly use. The last subsystem is brakes. So as I'm pretty sure you guys already know, brakes are responsible for stopping the car. So when the brakes are pressed, the brake fluid is released from the master cylinder and ultimately causes the brake calipers to contract and stop the tires from rotating. So that's pretty much in short what vehicle dynamics is comprised of. We do a lot of testing. We fabricate most of our parts except for brakes, which we tend to outsource. But we do a lot of testing, whether it be actually driving the car around and doing strain gauges, or doing kind of static testing of seeing how the suspension and the steering react when you're going through bumps and droops itself. So also as a side note, if anyone listening doesn't know anything about cars, I joined this club knowing absolutely nothing. So I just really like to ask questions, and I had a really good time. So if any of you guys are in the same boat, don't be scared off. It's definitely a really good club to join. But that's pretty much what vehicle dynamics is comprised of. So next, I'm going to pass it on to Sam.
Hello guys, I'm Sam. I'm the frame subsystem lead and I'll be introducing the chassis system to you guys today. So chassis basically deals with like the main body of the car. So we want to provide that like structure that all the other parts are mounted onto. And we also want to enclose the driver and make sure the driver is kept safe from any like crashes or rollovers or whatever might happen when you're driving over really rough terrain. So the chassis is kind of divided into two smaller subsystems. So we have the frame, which is like the metal parts, and the composite. So starting with the frame, it's like, the biggest part of that is the steel frame that you see in the picture that kind of is the main structure of the car. So like everything else, we start with our computer model. That computer model tells us like how long to make each individual tube and also helps us shape the ends of those tubes so that they all fit nicely together into that steel frame, and then we weld it. Basically, like this involves a lot of manual, hands-on kind of getting your hands dirty work. And you might see like a lot of sparks in these pictures, and you might be wondering like, does the frame subsystem actually involve that many sparks? And yes, the answer is yes. But anyway, moving on, we also have the composite subsystem. So composites makes the non-metallic parts of the chassis basically. So we have the seat. We actually make our own carbon fiber seat ourselves, which is pretty cool, as well as those red body panels. Those aren't carbon fiber, those are plastic, but we actually do use like a thermoformer to shape those body panels into the shape we want because not all of them are flat. So yeah, that is the chassis system. There has historically been a third component of chassis, but starting this year, we're kind of moving that out into its own separate thing. That would be the electrical system. So on the next slide, we're going to have Xiao, our electrical leader. He's going to introduce to you the electrical system. So Xiao, take it away.
Hi, my name is Xiao and I'm the electrical lead. Electrical, as its name states, is responsible for the electrical part of the car, that being the brake light and the kill switch. Although neither of them require complicated skills, a lot of techniques such as soldering, crimping, heat shrink tubing, and wire splitting are used in making them. We're also responsible for a large portion of testing, because testing requires collecting and storing data, and the most convenient way to do so is through electrical means. That being said, we're responsible for making data acquisition devices, and the first step in doing so is to identify the right sensor needed for that specific test. Let's say we want to know the stress a particular tube on the frame undergoes. We can string the strain gauge to the tube. The next step is to make a circuit for that sensor to work. A strain gauge, for example, needs a Wheatstone bridge to give a voltage signal and an instrumental amplifier to amplify that signal. Then, we need a microcontroller to store and collect that data in a way that can be analyzed in the future. The last step is to move everything you make into a sturdy platform so that your device won't break during the test. This is it for electrical. Now let's welcome Dan to talk about software.
Hello, I'm Dan. I am the Motorsports Secretary, and I will be facilitating the software projects this year. This is the first time Motorsports has supported software development projects, as there is a developing need for people who are familiar with writing software. So the highest priority of which is to aid the testing operations that are going to be taking place once our facilities reopen. So as mentioned, we'll be designing our own data acquisition system. And for software, this will include like the selection of our microcontroller, developing our data storage systems, and developing and testing extensively the software which will control the DAC. At some point, to aid vehicle dynamics members, we want to work on the development of a suspension simulation software. A user will be able to input the suspension coordinates of their design's components, and the software will output the resulting characteristics of that design. In addition, the software will generate a 3D render. So to accomplish this, the project is going to be broken up into three components: the math, which will be aided by vehicle dynamics members and resources, the user interface, and the render itself. While all of these components are dependent on each other, the development of each section can happen concurrently. With regards to the website, I'm looking to put a small team on the website redesign project. This will likely be using like the standard HTML, CSS, JavaScript suite, but I'd like for the team to have relative freedom in terms of the design and their implementation. These projects will be kicked off in following a few weeks of education. While I know some of you have prior knowledge and I actually recognize some of your names, I need to assume that everyone is new to software development. We will begin with some of the basics of the C language, the first session of which will be announced in our upcoming GBMs. All of these projects, along with experience on the team, will make you a more qualified candidate in your search for internships and jobs. You can use these as actual references to show your potential employers what your work looks like and the experience that you've gained with this club. Now, I would like to pass the presentation back to Red to discuss the CNC and CAM operations.
Cool. So for CNC and CAM, the CNC and CAM sub-team, we have to be the ones who create the programs that automated machines run to make complex parts. CNC stands for computer numerical control, and CAM stands for computer-aided machining. Both of these are very important for the automated machining process. There are over 30 unique parts that we have on the cars, from the hubs that are shown just over here, to our gearbox case, which Nina's talked a bit about before, and you can see it on the right over here, to other things like the shafts that are needed for the car, and a lot of these just can't really be done using conventional methods. Operators need to be trained in order to really take apart from a CAD model to create a CAM file which has all of the necessary toolpaths for cutting the part out, and then convert all of that into a language that the machine can understand. In doing CNC work, you gain a large understanding of how things are made and manufactured, especially more complex parts like, again, the gearbox case or the hub shown here. And really, this helps you understand certain limitations in design features due to things like sizes and shapes of cutters, as well as the need to like really hold the piece and clamp it down. So I will now be passing it over to Nick, who will be talking more about the new member incorporation and education process.
Next slide, please. Hi, I'm Nick. I'm the Vice President. As Red said, we plan to optimize four-wheel drive this semester, and we hope to have you all help with a wide variety of tasks. You will be able to work on a project under the supervision of or directly with a current member, and they will assist you with as much help as you need. Just a few examples of projects you can work on. Powertrain, you can work on optimizing gear trains to remove gearboxes. For vehicle dynamics, you can work on selecting new shocks and determining the correct positioning of them for desired handling characteristics. For chassis, you can analyze the firewall to determine which members can be modified to make it more compact. For electrical, you can design circuits for testing, utilizing potentiometers and strain gauges to gather suspension data. For software, you can develop a program to optimize suspension, as Dan said. And finally, for CNC, you can work with Red to learn how to program the CNC and plant toolpaths. Whichever system you choose, you will be given meaningful tasks, which, depending on how much you want to take on, can be even as much as leading the development of a component under the guidance of one of our senior members. For example, before joining, I had very little experience doing anything. I started out by helping our suspension lead Nikita make small modifications to our control arms. Then I was asked to redesign them based on certain dimensions and strength criteria. To do so, I did calculations and simulations. But now I make improvements and modifications independently, and I'm the go-to person for the control arms. Overall, this is a low-risk environment. We can learn how to create a real component and see how it performs at the end of the year at competition. Next slide, please. So every year we hold an endurance race for our new members, but sadly this year it will be postponed. This semester, instead of a race, we'll hold a design competition similar to the design presentation of the competition we compete in. During the semester, all the new members will work on their design projects using the engineering design cycle, which we will go over tomorrow at our first new member lesson. The design cycle is essentially the process in which you take a component from an idea to final production. Then in December, we'll have a panel of judges, which might even include some alumni to judge the designs. Next slide, please. So for some important dates, to help you learn how to implement the design cycle, we're holding a series of short lectures over the next few weeks. Our first lesson is tomorrow after our GBM at 5:30, and it's on the engineering design cycle. So this will be about a 15-minute overview of how you go about designing your component over the course of the semester. Lesson 2 will be this Saturday at 11 a.m., and it's on general engineering theory. Red will basically be doing a speed run of the mechanical engineering curriculum that will give you a basic mathematical understanding of the car. We also have lessons planned for system overviews, manufacturing techniques, and SolidWorks CAD. Starting tomorrow, we'll have GBMs on Fridays. Tomorrow, the GBM will start at 5:30 p.m., but all of the following GBMs will be at 5 p.m. on Fridays. After the system overview next week, after the GBM, we will ask you to fill out a system preference form where you select which system you want to join. By September 25th, we plan to send out the system assignments. To add all these dates to your calendar automatically, you can go to stonybrookmotorsports.com, scroll down to the bottom of the page where there's a calendar, and click the little plus button. It'll automatically get added to your calendar. So next slide, please. Next slide. Okay. So again, this is the QR code that Red showed you earlier. You can use your phone to read this. It takes you to the forums page where you can sign up for our Slack. Alternatively, you can go to stonybrookmotorsports.com, and at the top bar, there's you can go to resources and then forums. And for the semester, again, the most important item on that page is the Slack page. We post updates there and do most of our communication there. We will be posting the dates previously listed there also, and the safety courses listed are good to take for the future to enter the shop, but are not required for the semester. That's it. Thank you.
Cool. So with all of that, that's really all that we had prepared for today. If people have questions, you can feel free to ask. This section will still be recorded, so if you want, you can ask either through just unmuting yourself and speaking or through the chat. So do we have any questions?
So, all right, I joined on.
You can go ahead.
All right, okay, thanks, man. So if I joined on Slack, do I just like show up to the general body meeting on Friday?
Yes, so the GBM will be through the same link as this one. Yeah, right. we'll post an update later tonight, just with all the meeting times and such.
Okay, cool, thanks.
I saw the dates that mention of the GBM meetings. What were those bold dates for? Just to highlight the GBMs? Is that it? Was that what the bold dates are for?
Yes.
Yes, yeah, generally there's the GBMs and some major dates, particularly let's say with the 18th, we're going to be sending out a form just basically to ask people what their preference is, whether it be vehicle dynamics, powertrain, chassis, electrical, software, CNC. Yeah. So like generally just GBMs, which are important because they disperse general information as well as the important dates.
And then for like the non-bolded dates, which have the quote lessons on it, will we be using the same link as that what we used today?
Yes, all of them should be through the same link. Yes.
Okay, thanks a lot.
Yep. One thing of note for all of these, we highly recommend, whether or not, even if you're electrical or software, that everyone attend all of these. They will also be fully recorded, so there is not, if you miss it, no worries, it'll be posted probably in the same general location as the link for this. We just really want to make sure that everyone is on the same page, because let's say if you're in software, we want to make sure that everyone knows what they're really programming for, especially if you're, let's say, making a suspension analysis program. You want to be able to at least have a very basic understanding of like what a suspension is, how does it move, that kind of stuff. And to clarify a question in the chat, you do not have to be CAS. You can be any major. We've actually, 2 years ago, had a vice president who was a bio major. We've also had other forms of majors like chemical engineering, physics, AMS. So as long as you're interested in the team, you're more than free to join.
In regards to like programs and stuff like that, I realize that you guys mentioned for CAD we're going to be using SolidWorks, and in regards to like the software end, it's going to be variations of C or C++. My question is, how do we get access to SolidWorks for free? And if, like, for me, I learned Java, so like, is that going to matter?
So for the CAD side of things, as the CAD lesson comes up on the 18th, we will work on getting people set up with licenses. So that's an announcement that we'll have to hang tight for in a bit. As for the language, again, Dan will be teaching everything from the perspective that people are not going to have any experience. So Java will definitely be helpful in that it'll be some amount of experience.
Yeah, you just said everything I was going to say. So
yeah. In terms of fees associated with membership or attending a competition, we don't charge people to join, just because we feel that anyone should be able to join regardless. There is an associated fee with attending the competitions only when they're in person. So last year we actually had the competition went virtual because of the whole COVID pandemic. There were no associated fees, but generally the fees are meant to cover travel and hotels. For reference, it's only usually about $250, which for a 4-day competition is really not that bad. Obviously, if people have troubles with that, we can help them out.
Don't forget the SAE membership that they did charge us. That was $35, but that's it.
Yes.
That was it.
SAE has some membership thing which also costs $35. That is necessary for going to competitions. So yeah, actually, in the case of virtual competitions, there's also that membership fee, although I believe some of our members did not pay and didn't need to in order to get in. So take that for what you will. Yeah, are there any other questions? All right, unless there are any final questions that are not people just memeing on me at Nick, that is it. Everyone's free to go, and thank you so much for stopping by. We hope to see you tomorrow at 5:30 for our first lessons. Again, if not, no big deal because it will be recorded. So again, StonyBrookMotorsports.com, join our Slack. Thank you so much.
Thank you.
Thank you.